That was terrible. That was terrible. Okay, they rehearsed that, but it still sounded bad. All right. Well, kind of. I don't know. All right. So, so we filled this sheet out. This sheet goes right along with. Oh, I'm delayed. Goes right along with the notes that we're talking about. So if you would rather use this sheet, that's great. Do it. So have this sheet kind of handy when we go through these examples. I like to still go through the notes though because it gives us some examples at the bottom. Okay. And we can practice plugging this stuff in and knowing what these look like. So this is on the backside of your little, whatever these parent function guys, right? Backside of your transformation grid. They are like constant functions. They are the identity function, which is a linear function. This is an absolute value function. Square root. They call it squaring function. That's interesting. That's a quadratic function. And this guy is a cubing function or a cubic function. Okay, I like our words better. But anyway, there's all of those. Okay, those are kind of the main ones that you should remember in addition to some of the other ones that we went over at the bottom of your transformation sheet. So, shifting graphs. This is vertical and horizontal shifts. Okay, so up, down, left, right. If it is in on the outside of the function, when you're adding, that means up. This guy means down. So you are taking the original function f of x and you're just adding a number to it, or taking the original function f of x and you're subtracting a number from it. Okay. This guy right here is f of x minus c. That means x minus c is going inside of the parentheses. So this is going to be to the right because negative actually means to the right. It's the opposite of what you think. And this guy is left. I don't know why I started writing down. Left. Okay, so plus inside means left, minus inside means right. Okay, so let's do this. Example 1, they say, what is happening to this thing? Describe each transformation. If we start with x to the third power, you always want to pay attention to this guy, what they give you to start with. We're starting with just x to the third power, so I need to figure out what this minus 1 is doing. What does that minus 1 do to my function?
Down
1. Down 1. So if I know that x to the third power is this guy, all I have to do is shift him down 1 and I have my new function, right? He looks like that, okay? It makes him way easier for me to graph than plotting points. Okay, number 2, what's happening there? There are two things that are happening.
Down 1.
Okay, now which one comes first? Okay, it says left 2, down 1. Well, part of that is wrong.
Up 1.
Okay, the 2 comes first. So you're going to go left 2, and then you're going to go up 1, okay? So again, here's how I determine which one comes first. If I were to plug a number in for x, would I add the 2 or would I add the 1 first? I would add the 2 to it first. So that's what's going to happen to it first, right? Left 2 and then up 1, okay? All right, now reflecting graphs. If it is a negative on the outside of the function, it's x-axis. If it's on the inside, it's the y-axis, okay? So, first one, g. If we're what's our parent function? Pay attention to that. What's the parent function? Just the square root of x. So there's that guy. Sometimes I'll underline him or circle him or something just so I know what I'm starting with. Now, the negative's on the outside for a. So a lot of times I'll be lazy and I'll just say over x, right? I'm going over the x-axis. So, this guy to start with, the absolute value function looks like this. Okay, or not absolute value. The square root function looks like that, so I'm going over the x-axis, so my new one looks like this, right? This is the new part, okay? And I know that since I know all the shortcuts, okay? Rather than plotting the points. What about b?
Over y.
This is over y, or reflect over the y-axis.
What?
Over y, so he goes this way. That's the new one, okay? So that's the difference between them. Okay, now. Couple things that are happening for part C. Couple things happening for part C. First, what's happening first? 2 or negative? Which one comes first? The 2 comes first. What's the 2 doing?
It's going left.
Left 2. Left 2, and then over which one?
X.
Over x. Left 2 over x. Okay? So, the original function, which looks like this, is going to the left 2. Which now would be this guy, okay? And then he's going over the x, so he's going like this. So this is what the new part should look like. That's what my new function should look like after I transform him. Again, we're doing these so it makes it easier to graph instead of having to plot points. We hate that. Okay, backside. Couple more things. Those were all called, so horizontal shift, vertical shift, reflections, those are all called rigid transformations because I am not changing I am not changing shape or size. Shape or size. That's why it's called a rigid transformation. I am not changing the shape or the size. Now, we're going to deal with non-rigid transformations, which do change shape and size, right? Do change shape and size. That would be like stretching him out, right? So if I have like a parabola of some sort, maybe like this, and let's compress him. Let's compress him. Let's do a horizontal compression. So if I compress him horizontally, he looks like this, right? Okay? All right? So those are called non-rigid transformations because we are changing the shape. So change in shape. Change in shape. Okay? So they call them a vertical shrink and a horizontal shrink. I call them compressions. So that's what I'll call them. If they call them a shrink, though, then just be aware of that. So vertical compression, horizontal compression, vertical stretch, horizontal stretch. Okay? All right, and they are labeled as such on your grid. So compare the graph of the function. What's our parent function?
Absolute value.
Absolute x. Okay. What's the 3 doing in A?
Stretch.
How?
Compression. Just stretch.
How?
Compression.
Which
It's
one?
a vertical. Vertical.
He's vertical. Vertical stretch by? Vertical stretch by 3.
By 3. The other one's vertical compression by 1/3.
The other one's vertical compression by 1/3.
Whoa! Shut up.
Woo!
Stupid.
Okay. All right. So, A. On the next one, what's our parent function?
Horizontal. Shoot.
Parent function 2 minus x to the third. That's a really weird one to start us with, but
Put
that's
them in
okay.
order. Negative x.
Okay.
2/3
So they want us to let's first determine what this thing means. What does 2x mean? If it's inside parentheses.
It's a
Horizontal compression.
Horizontal compression by what?
By 1/2.
By 1/2, right? We have to translate it into the fraction form. Okay. What about the second one?
Horizontal stretch by
2.
Right, horizontal stretch by 2. Okay, so now they want us to actually write the function. So we didn't even need to know that information, but it's kind of good knowledge, okay? So they want us to actually write what this function looks like, okay? Compare the graph of the function, blah, blah, blah. Let's go ahead and write the function. Well, no, actually we did. Compare the graph, so we want to know that it is a horizontal compression. But let's write the function out. So what does f of 2x look like? We're going to call it g of x. Do you see why it says we call it g of x? G of x equals the new one, which is f of 2x. We plug 2x in for x.
yes.
Okay, this is how this works. So, equals 2 minus 2x to the third power. But we're going to rewrite him. G of x equals 2. And then what?
Negative 2x.
Minus 2x to the third power. Yep, 8x to the third power. We're going to cube both pieces. So, cube the 2, cube the x. Yeah? And that's all that we can do for that first part, okay? Now, the part B, they call it h of x. And here we are plugging in 1/2, right? So, 2 minus 1/2 x to the third power. All right, let's simplify him, get rid of the parentheses. H of x equals what? 2 minus, yeah, it says 1/8 x to the third power. And this is right, she is right. And this is right, they are right. Okay, those are those guys, okay? So be careful what they're asking for, if they're asking for the function or for you to describe what it is. Whatever, okay? All of those things mean the same thing. All right, there you go. Any questions? Anything else for the good of the cause? This is a really short video. This is like the shortest video I've ever made, maybe.
Hola, my name's Dora.
Oh my God, kid.
You're stupid.
All right.
Okay, I did my assignment. I thought the assignment was due today, so I did it. I thought